Hey, friends, I'm Scott Hanselman,
I'm Scott Hunter.
and this is our stage, our virtual stage. We're very happy with what Ashley McNamara put together for us. It's almost like we're here. High five.
Yes.
Cool.
Um, and we're here to talk about the journey to one.net, which has been something that Scott and I have been talking about almost since we joined Microsoft, many years ago.
It's part of the master plan. We've been trying to put together an insane master plan for so long with the help of all of our friends on the .NET team, and we're getting really, really close. We open sourced everything, and they haven't stopped us yet, right? What else have we gotten away with over the last?
We made it all cross-platform, Scott,
It runs everywhere, basically everywhere. Runs on your watch, runs on your phone, runs in a dozen Linuxes. Cool.
and we're still here.
And we're still
Um,
here, and they haven't turned off our internet yet, and our badges continue to work.
so let's talk about some of this stuff. So, .NET when it first came out was all about desktop and web, and over the years we've added more and more workloads as we move forward. We've added cloud, mobile, gaming, IoT, AI. We're going to show a couple of these today. These are all the new places. So we think of .NET as something that you can build any app for any platform for any kind of thing.
You know, I,
Um,
I really like this, the aspect. If you actually go back one slide, this is really important because there are people out there who are maybe like they identify as like, oh, I'm a web developer. I'm a .NET. I've only written games in .NET. Like you maybe are writing a Unity game in C Sharp, or maybe you've only done some mobile apps with Xamarin. You actually are all of these different developers, right? Like once you know how to do this stuff, you actually have more power than you maybe realize, and that's what I think is so great about the platform.
yeah. Um, let's talk about the health of .NET. So we shipped .NET Core a couple of years ago. It's only been 2 or 3 years, and we've already eclipsed 1.5 million developers. In Stack Overflow's developer survey, we are the number one most loved framework. And one of the most exciting ones to me, Scott was mentioning earlier that we open sourced, but we really open sourced, meaning that we're one of the top highest velocity OSS projects in GitHub, which means we didn't just throw it over the fence. People are actually in there filing issues, filing PRs. We're in there doing it all in the public, and I'm super excited about that. Language-wise, C Sharp is one of the top 5 languages in GitHub. We have focused heavily on performance the last couple of years with .NET Core. The Tech Empower benchmark, we are always in the top chunk of that benchmark. 7 times faster than Node.js, faster than Java. And so that's a commitment we're still working on as we move forward. And then as we look at surveys of our new customers, we're seeing lots of new people come in. Lots of our new customers are students.
Very cool.
If if we look at how much .NET's growing, in the last year we added 1 million brand new .NET developers, which I think is a great number. .NET Core grew by 600,000 in that same time frame. So you can see a lot of that growth is .NET Core. And the crazy one is, we only started doing Linux a couple of years ago, and we had 1 million publishes to VS to Linux. So we can see that our customers are embracing Linux on .NET Core.
I've actually recently moved a lot of my personal websites from Windows to Linux to get a little bit lower cost in Azure and also a little more density. And I'm doing everything now in containers. And moving even a 15-year-old .NET application over to .NET Core and then into Linux, like it works. Like it's straightforward. It wasn't super easy, but it was totally possible.
Well, we're going to show later today how easy it is to develop on Linux with Visual Studio.
Cool.
So, .NET Core 3 is also our fastest adopted version of .NET ever. Historically, .NET took years for people to move to the next version, and now we're finding in just a matter of 2 or 3 months, the majority of our customers are on the latest version, which is what we want. We want our customers to take advantage of the newest features as soon as possible and not wait forever on old versions. Stack Overflow, one of the places you go to ask questions, they moved their entire platform over to .NET Core 3.1, and they saw better performance, better, faster development, and all kinds of improvements by making this change. And so that's an example of a huge customer that's actually moved their entire workload to .NET Core 3.1 this year. So let's talk about what's new today. So First off, we are just released Blazor WebAssembly. And so we shipped Blazor in September of 2019. And that was the server version of Blazor, meaning that all the app code ran on the server, and we sent the updates to the client. So you get a very lightweight client, and all your heavy lifting's happening on the server. Now we have Blazor WebAssembly, and that WebAssembly lets you actually run C# directly in the browser. And that's cool because for the first time ever, you can actually write a C# app that runs in the browser and can be completely offline. And you can also make that into what we call a portable web application, which is an app that can be installed on the desktop. So it lets you take your web learnings and experiences and use that to build more native-y kinds of apps.
So let me make sure that I understand this for a second. So Blazor server is out. It's been out. It's long-term support. People can use this, have been using this, and they'll be supported for years. And that means that the view that's being updated is being updated with a communications a pipe that's basically open, and like you said, Blazor runs on the server. So the .NET code that's doing the work is on the server, and then what's on the client's kind of like lightweight. It's simple. It doesn't use WebAssembly, and it can work on any browser, right?
Right, and there's a benefit to that, meaning that that application is going to be very lightweight. The number of bytes that have to cross the stream to the browser are very small. Only the deltas of a UI change, and so you're going to find it's going to be a lighter amount of data coming into the browser than you would see with, let's say, a regular AngularJS or React or Vue or something like that. You're going to get a super lightweight version because of that.
Okay, so then now Blazor WebAssembly gives you the option to take all that stuff from the server and offload it, and you've got this great runtime in the browser. It's maybe a little bit heavier up front to get started, but once it's there, the communication that's going across the wire is really just the data that you want. And you just said that could be offline. You could sever that connection, and the app will keep running.
Right.
That sounds amazing.
Yeah. So let's jump into this. So let's do a quick demo of Blazor WebAssembly.
All right.
So I'm going to jump into Visual Studio here.
Mm-hmm.
And what I'll do is I'll just create a new project. And I want to show you some of the features that you have here. So when you create a Blazor project, you're going to see here that now I get the option of doing a Blazor server app, what we shipped in September of 2019. And now you have this new Blazor WebAssembly app. But all the features of ASP.NET are still here. Notice I can set authentication. So if you want to require people to log in, you can do that just like you could for a regular ASP.NET app. I might want to have an ASP.NET backend to host some of my APIs. So, my Blazor app can call these APIs. If I check that box, I get that. If I want to make a progressive web app, that's an app that can be installed directly on the desktop. I just check that box, and I can, run the app directly on the desktop, and we'll show that. Now, I'm not going to do that right here. I've already got a project loaded, so I'm going to cancel this out.
I love progressive web applications.
And let's switch over here to a Blazor WASM app. And so what I'm going to do first is we'll just run this in the browser.
Mm-hmm.
And this is the traditional demo that we've, our application, this is the final new application we have. It's got a counter button that you can press, and it's got a page that calls an API, displays some UI.
Mm-hmm.
And I wanted to show a few new things here. So first off, we've done a demo before, Scott, where we show that you can actually, well, how do you prove this is actually running, on the client and not running on the server?
Right.
And we've had this thing where you can basically launch the debugger. And when you do it, you press Shift-Alt-D. That will launch this, and it tells me I have to restart Edge enabled so that we can actually talk to the debugger.
Right. So the Edge is going to open up a port and listen on that port, and that'll allow people to communicate it with. And it's an explicit thing. You can't do this without launching Edge in this debug mode. And then here you're going to enable that. You just copy paste into Windows R. Starts right up again.
And now I can press that same keystroke again, and now the debugger is going to come up.
Okay.
And so we'll click over here to File, and we'll drill down and open the folder, and we'll find our client here. Here's our pages.
All right, but hang on, though. That says that says counter.razor. That doesn't say whatever.js.
Right. That's the same file you would see in Visual Studio. That's the same exact file. And notice here that I've got a breakpoint on the increment count. So when the button is pressed, the source code. Also notice, Scott, this is C# source code.
Yeah, that's the thing that's kind of got me going. Hang on. So counter.razor. So this is the development tools that you see in this Chromium-based version of Edge. You're not seeing a bunch of transpiled WebAssembly, JavaScript, blah, blah, blah. You're seeing C# in a Razor file.
Yep. And if I come over here and click the button, you'll see we paused in the debugger.
Ooh.
And if you've seen any of the demos we did before this stuff was actually RTM, it sort of worked. But now you can see the variables show up. You can see there's a 0 there showing me that it's actually inspecting the variable. I can look at these things. So all this stuff is available for me to try.
That's great.
Press F8 to run it again, just to prove the point. Click it one more time, and now you'll see that value is 1 in everywhere.
So that's really nice, but not everyone's really familiar with F12 tools. Like for people who are Webby people, they might say, "Oh, great! I can use C#, I can do Razor, and I can see this lovely F12 that I'm familiar with," and they might like that inspector. But not everyone's into that.
Yeah. So we also did the same tooling, so you could actually do all this debugging and stuff directly in Visual Studio. So let's show that real quick. So what I'll do is I'll close this out. Now we're in VS, and what I'm going to do is I've got a couple of breakpoints. What I've done is I've got a breakpoint here. This is the fetch data file, and so this is a Razor file. Scott, see this? Let me just put some zoom on here. Minimize this. I want to be very clear. This is a Razor file. So a Razor file is what goes to the browser.
Right.
So this is a client file. And what I did is in this client file, what it does is it does a for loop and shows some weather on the screen. To get that weather, it makes a call to the back end right here, calling forecast get from JSON async. So I put a breakpoint before the call there and a breakpoint after. And then in the server, this is my weather forecast controller. Typical controller you'd have in ASP.NET. This is the API that I'm going to call, and I put a breakpoint there. So I'm going to show that you can put a breakpoint on the client and the server, and we can do full stack debugging with this tech.
Okay, to make sure I understand, then fetchdata.razor is a client-side thing that is running in specifically Blazor WebAssembly. That's the new thing that we have not been able to do until it's released today.
Yes. You could do that debugging that we showed you,
over in the browser.
That only got you part of the way there. And so we'll let this app run for a sec here and boot up.
So you just pushed F5, like this is integrated into Visual Studio. You just pushed F5 and then you have these breakpoints.
Yep. You can see over here that Visual Studio's diagnostic tools popped up showing you that kind of stuff. The app's going to load up here and get going. I want to call out one more thing about that fetch data page. Let's go back to the fetch data page, and I want to see this, Scott.
Yeah, the attribute authorize.
Authorize.
Because you had said individual accounts, right?
Actually, enable user accounts in this application. I've done that for this app, and so when I click fetch data, the first thing that's going to happen is, well, I have to log in, and this is going to be the traditional ASP.NET, authentication mechanisms that just work just like you would expect.
And that's a regular attribute that people who do web APIs or MVC model type stuff know how to do.
Right. And the cool thing there to me is we don't require you to do any crazy stuff. Just put a single attribute on the page. We'll take care of all of it for you.
Cool.
Let's press the button here. It's going to ask me to say my password. And now what's going on here is, look what happened. Now my breakpoint just hit in the client. And so I'm going to press F5, and it's going to call this call to the server. Now my breakpoint hit in the server. It's going to return that data.
You did an F10. You did a step over and jump from the client to the server because you made that call, and now you see that the call stack is Blazor on the server.
I'm on the server, and let's go back to the client. Remember, I put a breakpoint on the client on the return side.
And now we're back.
If I will hover over forecasts, you can see
Look at
all the
that.
data flowed all the way through.
I see. So it's a bridge. It's a bridge across because you started Edge in that debugging.
Because I started Visual Studio and with the debugger in Visual Studio,
Ah,
it hooks up client debugging and server debugging. We call that full stack debugging.
automatically.
Automatically, just works.
Wow. And you didn't have to start, and then we were doing with F12 debugging, you had to do start Edge in that fancy way. In this case, Visual Studio did everything for you.
Does everything for me.
That's
I do
cool.
nothing by myself. I want to point out one more thing here, real quick. We talked about progressive web apps, Scott.
Ooh.
There is that install button up here in my browser,
Yep.
which allows me to basically install the app. Now the app is actually a desktop app.
Mm-hmm.
You can see there's no browser Chrome around it anymore. If I go to my start menu here, it shows up as a first-class citizen. From here, I could decide to uninstall it. And so I just want to talk, show that PWA kind of experience real quick. Let's close out this app, and then I'll show one more example of this, and we can move on.
Cool.
So let me
Yeah,
jump to
PWAs
my
are
source
fantastic.
folder here.
The PWA stuff in the new Edge is just lovely, and I've got a number of apps that are pinned. I've got Twitter. I've got, you can even run Teams as a PWA if you want to. Making them is really easy. You just need a manifest, and we take care of all that for you.
So this is an app that Steve Sanderson is going to show in some of his demos that he and Dan Roth are working on in Blazor full up as well. So you'll be able to Google and find some of their talks. This is a full application, which we'll get back to in a little bit as well.
Right. It's more than just to click a button to make a number get higher.
Exactly. This is a real app, and it's actually designed to run potentially even on a device. The app is imagine you're renting a car, and when you rent a car, when you return it, there's somebody there, an attendant, that will look at the license plate, look up the car, and put in your mileage and all that kind of stuff. So let's do this. I'll log in.
Okay. I love that 10 minutes of our talk is you logging in. If only there were a way to automate that with like a password manager of some kind.
I have a password manager there. I'm just not
If
using
only
it
you
for this.
used it.
Okay, so I'm in this app, and it's an app designed, to I'll show it in a second, to fit on different screens.
Sure.
I can start looking up your license plate. That's the car I'm going to choose.
Ooh, 3D.
And this is a JavaScript library. So Blazor is really cool because it integrates really well with JavaScript. And so in this case, we're using a JavaScript library to show the car. And what I might do is I might come over here and go, okay, well, you added this number of miles. Hey, let's do something cool here, Scott. Before I run that, I'm going to go over here, and I'm going to turn the network traffic on this app off.
Really? So you
We're
just
showing that
airplane
PWA,
moded the app.
This offline app.
Okay.
And so I pulled that over there and turned that off in the tools.
Huh.
So I'm going to make a change and say, yeah, he brought it back with half tank, and I'm going to make a note that there's there's scratch on the window, and
Okay.
I could take a picture here if I wanted to. I don't have a window scratch, but I'm going to just put a fun picture here anyways.
That looks like a window. Sure.
And I'm going to press save.
Okay.
And save. And notice this.
Ah, could not sync. It's holding it somewhere in
network
local
offline.
storage.
Exactly. This app is writing to local storage. And so it's designed to be able to run offline. As soon as I turn it back online, and hide the tools here, I can go over here and click retry. And now my updates are there. And if I look that back up again, there's my notes.
Look at that. See, so that, because if you're a car attendant, you're in an airport parking lot and it's spotty connection, you can't get Wi-Fi, you're underneath a bunch of concrete. maybe you have this on a device or a tablet. You want to be able to come and go, and you don't want to think about that stuff. Usually people think about that kind of functionality as being something you get like with a full app, but this is .NET. It's a full app. It's a progressive web app. It can be installed. Then I assume you could do the same install and put it in the pin in the start menu.
Yep, right there.
Look at that.
Now it's a progressive web app.
Lovely.
Into my menu there. That simple. So that's
I dig it.
Laser. So we'll close out of this one.
Mm-hmm.
And let's go back here and let's talk about WinForm Designer. So with the version of 16.6 of Visual Studio, we are starting to finish the WinForm Designer support. We have a designer that will be in the product in 16.6. It's available. And you're going to notice here that in 16.7 Preview 1 and Preview 2, we will finalize all the controls for the designer. So all the data controls and stuff. So we're only 1 or 2 preview releases away from having that done. And then when 16.7 RTMs, you'll have all the controls that people use. And then we also are starting to work with our third-party control vendors so their controls show up as well. So making a nice step in WinForm Designer.
Let's dig a little into that, if you don't mind, for a second. If you would just go back, why is that important? Because you're saying Windows Forms Designer. Maybe I've been in the business for 20 years, and I've been using a Windows Forms Designer for many, many years with success. I've been doing that on .NET Full Framework, and with the .NET Full Framework, I have to make sure that my local machine has the right version of .NET. It's .NET's 4.7 or 4.6 or 4.8. With .NET Core and Windows Forms, I can now ship the entire .NET Core runtime. I can publish it and put it all in a folder, and I could hand you a USB key with a Windows Forms app on it with .NET Core, like right there. I don't have to worry about it. So what we're bringing is the Windows Forms Designer to that world of .NET Core, and then you get all those benefits of .NET Core. Is that right?
Exactly. I mean, the big benefit is once you make that exe, that single exe, it means a Windows update or any updates to the machine won't break your application. You know, historically, because .NET Framework has been this global thing installed on the machine, if an update happens to fix a security patch or something like that, well, maybe your app is, gets busted by that. Now we give you the control to decide when you want to take a new framework and make a single exe. And we're going to show that single exe in a little bit.
Yeah, that's a really compelling reason. If you're wondering why this matters and you have a company, or you're working at a company with thousands and thousands of people that have Windows Forms apps, and you're waiting for the entire company to upgrade to a version of Windows or a version of .NET, you can kind of take control and do a lot more. And there's a bunch of new improvements in Windows Forms around high DPI and 4K and things like that. So there's lots of really compelling reasons to move Windows Forms to .NET Core.
Speaking of Windows Forms, because it's open source, we actually just took recently a PR for the first new control that we put in Windows Forms in like a decade.
Don't sleep on Windows Forms.
In .NET 5, Windows Forms will actually have a new control written by some third parties.
Cool.
So let's talk about Model Builder. We shipped ML.NET about a year ago. Sometime in, I think it was build 2019 is when we shipped this thing, which was in May of 2019. And, both you and I, Scott, we don't know a lot about machine learning, but we built a cool tool into Visual Studio called Model Builder, which makes it easy for people like you and I to do this kind of thing. So let me show this real quick.
Mm-hmm.
So what I'm going to do is, let's go back here and we'll launch the card checker again.
All righty. Maybe you could write an ML or an AI that knows how to say that wasn't a window that you uploaded a picture of.
Well, is something broken or not? I mean,
yeah.
As an attendant at a rental car place, I might want to just take pictures of the car, and we can let AI decide whether that's something you're going to build a customer for.
Mm-hmm.
So I can just right-click on this project. This is now in Visual Studio,
okay.
And there's this new machine learning, add machine learning right here.
It's funny that you're doing that because I actually did that with my LinkedIn. I went right-click, add machine learning, and now I am third certified in machine learning. So
you see a bunch of different options here. Let's do image classification because I want to go take pictures of a car.
Mm-hmm.
And I have two choices. I can train on my local machine, or I could train in Azure. And you might want to train in Azure because, well, what if you want to let it run for a couple days, and you have a lot of data? You don't want your laptop to be or your desktop to be just stuck doing that for a long time, or you don't have great hardware. I can check the Azure, and it'll let me set up my account, and I happen to know that we've got that.
And when you're doing this, you're just paying for the training, right? You're not like you can't fall asleep
I'm paying
and
for the compute for the training. When I'm done, it all goes away.
okay, good. I don't want to like fall asleep and wake up with like a $10,000 bill. I just want to spin up a bunch of machines, train a bunch of stuff, and then get out of there.
Yep. So I can do it in the cloud or local.
Cool.
Now I have to give it some data, and so I'm going to go to that folder on my desktop. There we
Build.
go.
Yeah, there you go. Yeah. Okay. So when you open that up, if you've got a damaged folder and a not damaged folder, the folder name is a bit of metadata.
Yes. So when I click OK here, and I scroll down, you can see that the tool went and found the two folders, and I've got 920 pictures of damaged cars and 920 pictures of not damaged cars. What's going to happen next is it's going to go to, if I press start training, it's going to go and upload that data to the cloud. It's going to run for a long time actually in the cloud. And when it's done, the data is going to come down.
Okay.
So let's close this Visual Studio out. I've already done this, so we don't have to wait for it.
And you can decide, I guess, how long you want to run that based on how much money you have, whether you're running locally or running in the cloud. It could run for a half an hour and give you a good number. It could run for days and give you a better number.
Exactly. So here we are. I've got my results. So I'm going to click evaluate, and it says that, hey, 91% accuracy. It chose the model for me. It chose all of the stuff for me. But the most important thing for me is there's this button here called code. And what it does is I can say, go take the model that you created from this and add it to my project. And so 2 new projects just showed up here. There's this console app for training, or for just running some tests. And here's the model.
That's actually cool.
Added the reference to the model for me as well already. So all I've got to do now is come over here, and I'm just going to uncomment some code.
That's cool that you did that, because it didn't just drop in like one C# file. It actually made you a little mini solution. It gave you a console app with some sample code. It gave you a separate model library, which allows you to then use that from anywhere. That can be consumed from other projects, right?
And exactly. And all I've got to do here is call this model.predict and pass it in. It's an image, so the path to the image.
Okay.
And it will come out with a prediction.
Okay.
And so you can see before I had this hard coded. Now we'll set this to the prediction that came off the model. Press save.
So let me see if I understand this. Prediction has prediction and score, and then you're making a projection there on line 25 saying, all right, we're going to turn that into a type of our own. Damage detection result is a type you made.
Yes, and then we're going to return that back to the Blazor app.
I see.
So let's run this.
So we're just taking our Blazor app and we're enhancing it, and now it's just going to be a better app, and we've just sprinkled a little ML on it.
It's now an AI-enabled Blazor app.
That's going in our marketing paperwork for the car checker app, ASAP. Okay.
There we go. And let's go back and find that same car again. And it did have some damage previously over here. And now, because I've added this new AI, if I press detect damage, it's going to go run that picture through the model, and it's going to tell me it's damaged.
98% confidence.
So the attendant can just go around and take pictures of the car, and the AI can actually decide whether it's a damage level that they would want to charge you for.
Now, we did that training. We could have done it locally. You did it in Azure. We could also, I assume, now that we've written the consumption of that model, we could give that to an actual data scientist. They could go off and do other stuff, and we could they'd give us another model, and we could consume models from other places. Maybe they did it in TensorFlow, or they did it in WSL at the command line somewhere, and then they can feed us that model, and we just consume it. Is that right?
Yeah.
So there's a lot of flexibility with ML.NET, and I could make models today and then maybe refine them in another way with the help of a data scientist.
Cool. So that's all the new stuff that's available right now. And so kind of our message right now to any .NET customer if you're building a brand new application, .NET Core 3.1 is what you should be thinking about. It's got long-term support, so it's supported for the next 3 years. It's got WinForms and WPF support, so all your major app types from .NET Framework should be able to move over. As Scott mentioned earlier, it's got side-by-side support, which means nothing breaks. You can have multiple versions of .NET on the machine, and your app just stays the same. We now let you build these self-contained exes, which we'll show you in a second. And with Blazor, we let you build this modern web UI. You can build spas without even having to know any JavaScript. It just works. And there's a whole bunch of new C# 8.0 features that we've added that you can take advantage of as well. And so another part of this that's kind of cool is along this journey of building .NET Core and Blazor and WinForms, we've had a bunch of control vendors that are partner companies that help us. DevExpress, Grape City, Infragistics, Progress, Radzin, Syncfusion. All of these folks build Blazor controls, and all these folks build controls for WinForms and WPF. And all of this stuff works with .NET Core. So thank you to all these partners. Cool. Let's talk about the journey to one.NET, Scott. So background for folks, when Scott and I joined the company, we had this grand vision with a couple of other colleagues of making .NET simpler, smaller, easier, cross-platform, open source, and .NET Core was part of that journey. It allowed us to re-envision .NET and build it in a new way. And over the journey of .NET Core 1, 2, and 3, we've brought more capabilities and more APIs and made it easier for you to move your application to it. But there's one piece of it still left. We're still left with primarily there's .NET Core and there's Mono and Xamarin. What we want to do is take all of this and squish it together, and we're going to call this .NET 5. And the idea behind, actually I should say .NET 5 and .NET 6, because a lot of this is a lot of work, and we won't get all of it done in .NET 5. So some of it will happen in .NET 5, and some of it will happen in .NET 6. We're going to call that a wave. But the idea is you have one single SDK, and that means you download the .NET SDK, and from that you can build a WinForm, a WPF, a Xamarin, an ASP.NET, a console, any of the types of apps. In this world, we've actually had more than one base class libraries. These are like where strings and dates and stuff come from, because the Xamarin technology was built on Mono, which is an open source implementation of .NET, different than .NET Core. And then .NET Core has its own BCL. So we want to unify those two BCLs into one BCL. And so no matter what kind of .NET app that you're using, you're always using the same BCL. And we want to unify the tool chain, meaning that I can always go to a command prompt and say .NET new, I can do .NET run, .NET build, all of those things, and all of our apps work across that.
And if I may, that's so important, because if we remember at the very beginning of this talk, when we had that list of how all the different things you could build with .NET, and I mentioned that there might be someone out there who's a WinForms developer or a brand new early in career person who just started making ASP.NET apps, they might go to system.io.file in one app type and go, okay, I understand that, I learned that. And then they might go elsewhere and find that it's subtly different. They might find that, well, they told me I was working in .NET singular, and now I find out that there's multiple .NETs, like there were when you compressed in this slide here. That's the goal. You learn it once and it works everywhere and have a great experience everywhere. And that's the goal. And the point also you made was this 5 to 6 wave. Remember, we'll talk about this when we talk about support, but .NET 3 is LTS, long-term support. .NET 5 will be a current release that'll last for a year. .NET 6 will be long-term support. All of the even-numbered .NETs as we move forward are going to be long-term support. So by the time we get to .NET 6, you're going to have one .NET with 3 years of support. Get on board now. Do your LTS stuff in .NET 3. Start joining us on this .NET 5 journey. And then by the time we get to 6, you're going to be, again, on long-term support. It's a really nice, predictable way to think about things.
Yes, but as you said, long-term support, not only long-term support, but as you said, that first slide, we showed all those app types. Mm-hmm. All those app types will be in the same SDK, using the same BCL, using the exact same tool chain. So it's the first time in a long time we've kind of unified everything back together. But at the same time, I want to be very clear, it's not we're bloating .NET up. All of those things will be incremental. You can install the SDK and only put ASP.NET on, or you can only put WinForms on, or only put the mobile applications on.
Good point.
So this is plug and play. We're not going to ever make a huge monolithic bolted system, huge system again. It's going to be something where you can only put on what you need.
Yeah.
You don't have to. Yeah. So
we'll talk about micro stuff and making things really small. I'm going to challenge you to see how small we can get this stuff. So yes, this is just because we're squishing everything together doesn't mean it's going to be a bloated thing. It's going to be actually quite modular.
So, we obviously want to have awesome cross-platform UI, and we'll talk about that a little bit later. We want to have great cross-platform web UI, and we've already shown some of that today. We have awesome support for ASP.NET, and with Blazor, we give you the ability to have SPA-type applications that either run from the server or run directly on the client in the browser. And so we have some awesome offerings there for you. Cloud native, this is, you've heard all the buzzwords, containers and microservices and Kubernetes, and where does .NET fit into that? And we'll talk a little bit about that in a second. And obviously, we're always trying to make .NET better all up, whether it's the speed of the tools or the speed of the product, the size, diagnostics. We're always, investing everywhere. So let's move forward and talk about cloud native investments a little bit. So first off, we want to make it very easy to build an app with WSL. So WSL is a technology that's in Windows now that lets you actually run Linux. It's the Windows subsystem for Linux. You can run Linux directly on your Windows machine. And we're going to show that in a second. So we're going to let you control F5 and F5 a .NET app directly into WSL, which means you can actually develop on Linux on Windows. We also hear from customers that, hey, they want their microservices to be kind of small. They don't want to have to publish a lot of stuff. And so we're continuing to invest in how big, how small can we make an exe, and we'll do a demo of that in a little bit. And then one of the areas that .NET's not great at today is our tooling around building multi-projects and running them all at the same time. Imagine you've got a web front end that's calling a web back end that might have maybe a Redis cache somewhere. You have to manually start and stop all those components, and we want to make that a simpler thing, and so that's what Thai is about. And then the perf in .NET is so amazing that it ends up being good at building things like reverse proxies. And so many Azure services will actually run behind a reverse proxy written on .NET 5. So before we jump in and do the demos here, I want to point out a C# feature that we're doing as well. This is C# 9. And just Google Mads Torgerson, and you can find a bunch of other videos and demos and stuff where we talk more about this. Today, Scott and I are going to talk about top-level programs, which is a way of taking some of the syntax of .NET and throwing it away and making it just easier to get to your code. There's a lot more than just records and top-level programs, but that's what we're going to talk about today.
And you made, if I may, you made a comment in the slide before we talked about C# 8 getting on board with the long-term support in .NET Core, C# 9. If you want to have those great new versions of C#, yet another reason to get on the .NET Core train, because you can go and say, I want the current language, maybe I want the experimental, I want to play with C#. You can actually get involved in our design meetings. You can watch C# as an evolution become a more powerful language as we move forward to the next version of C#.
Yep. So let's do a quick demo here, Scott. So
this is great stuff because WSL 2 is out now. WSL 2 is, you can get Windows Update right now, and WSL 2 includes a real Linux kernel. So this is not, an emulated Linux. It's Linux on Windows. It's happening.
So let's just boot WSL up on my machine. And so when I run this, you're going to notice my prompt turned into a Unix prompt. Now I'm in Unix. You can see whack mount, whack C, user Scott.
Actually, would you do me a favor? Do you mind?
Yeah.
Would you run LSB_release space -A underscore LSB _release space -A. So you are on Ubuntu 18.04. Thank you, sir.
In my Windows terminal.
Yep.
So let's boot up the S. And let's create a new project. Let's just create a ASP.NET Core web app. And Name doesn't matter.
Okay.
And we'll just do a web app, and all that's fine.
And notice, I'm noticing something. People might be watching going, there's going to be a checkbox somewhere for WSL. He didn't push the WSL checkbox. What's going on?
No WSL checkbox.
.NET Core is cross-platform, runs anywhere. No need to push a checkbox because it'll run on Linux if you want it to.
I just want to check one thing.
All right, so here's our web application.
I wanted to make sure I didn't make a 5.0 app, so.
Okay, so this is a regular .NET Core 3.1 app.
Yep, it's 3.1 app.
Okay.
And all I'm going to do here is come here and make a quick change and maybe do an H2, and we'll do Environ Mint. Use IntelliSense, please. And what I'm going to do is basically, write some C# to actually spit out the version of the OS.
Alrighty.
So let's run this app. And what I would expect here is it's going to launch the browser and it's going to, print a Windows version.
Yep, and I just saw it say IIS Express, so you're on Windows 10. There you go. Your build number of Windows 10 on IIS Express.
So on my machine, I have a preview of some tools that are shipping later this year. And notice that WSL2 shows up in the launch list.
Ah.
So this means now when I decide to run this application, it's going to run in Linux, not run on Windows.
Cool.
So let's run it again. There's the Kestrel booting up. Here's the browser. And take a look at that, Scott.
That is actually the version of the Linux kernel. So when we did LSB release, that is the version of Ubuntu. It might say 1804, which is April of 2018. This is, in fact, Linux version 4.19.84. And you can actually go up to github.com/Microsoft. And under WSL2 Linux kernel, one of the things that's interesting about WSL2, when I said before, we ship an actual Linux kernel. That's a Microsoft compiled Linux kernel that is downstream from Linux itself. That way we're shipping one that has the features that you need to run great on Linux. That's the actual version of the Linux kernel right there, and you can go and see that up on GitHub because it's open source, the kernel itself. So that is a real thing. Very cool.
Okay, so I'll close this out. I want to show one final thing, and that is basically we've had support for this for a while. It's gotten better over time, and that is also if I actually do want to use containers, all I'm going to do is right-click, add Docker support. I can say Windows or Linux. In this case, I'll say Linux. And in the past, this tooling was pretty crazy. It would actually add a bunch of stuff to your project. Mm-hmm. We've simplified the tooling quite a bit now, where all you get is the Docker file. And the Docker file is just the file that goes and tells Docker which image to be your base image for your ASP.NET Core application. And then it tells it how to actually, where to copy your app.
And let me talk about this for a sec. A lot of thought has been put into this. You could, if you wanted to, make a super simple Docker file that would basically boot up a big old Linux, bring up all the Docker, bring up all the .NET SDK stuff, all the tools, the compiler, and this and that and the other thing, and it would work fine. I'm saying that in air quotes. It's fine. But what we're doing here is a multi-stage Docker file. So we're starting with the ASP.NET base image. We've got also a separate build image, and what's really cool is it actually builds in Docker, so the compilation happens in Docker, and then look at line 14 there. It outputs that into a build folder, okay? Then publishes separately, so the build, the publish, each individual layer can be cached. This makes your build really, really clean. And you'll notice it says show output from container tools there. The great new container tools in Visual Studio are fantastic. So individual stages. The final, though, builds on a runtime base, so you don't have to ship the .NET SDK with your container. When we say microservices, we mean micro. You only ship what you need to run. It's really nice, clean Docker file. I've been very impressed with how this works. And also, we've got Docker Desktop talking to WSL2, so those container tools are really running in Linux, which is fantastic.
So I'm not running the Docker Desktop on WSL2 yet, Scott. I'm running the regular Docker Desktop. But still, all these improvements, while we were just talking, because of these improvements we made in the tools, VS actually ran Docker and a bunch of Docker stuff.
Oh, wow.
behind the
So it was
scenes.
doing it. It was setting you up while we were discussing this.
And so now if I run it, it's actually going to start pretty fast because it's actually already built the container the first time. It's pulling my app to it.
Okay.
It's going to ask if I want to do SSL.
Right.
I'll say yes.
Yeah, it's definitely.
There's my browser down there.
There's so many people working between WSL, the friends at Docker, Visual Studio, the Container Tools team to make this like just work.
Exactly. And the long-term plan is to move even the Docker for Desktop to WSL as well. And when that happens, that'll make that experience even faster and more lightweight.
Don't close that tab. Notice the Unix. Okay, it was 4.1. That's okay. It was 4.19.76. That was the version of the Linux kernel in that base image. So we were pulling from Buster Slim, which had a different version there. So you actually saw, in fact, another version of the Linux kernel running there. Very cool.
Yeah, right there. Buster Slim up here.
Yep.
Okay, cool.
I like it. That was pretty sweet.
So let's go back to slides for a second.
Mm-hmm.
And the next thing we're going to show is going to be single file. And so this is that feature we have where we can basically take your .NET application, compile .NET into it, and your application into a single file. So let's show that. So I'm going to jump out of here, and we're going to jump back into the Windows terminal here.
I love single file.
And what I've got is I've got a 3.1 web application. And this is the command you would run to basically produce a single exe out of that. You can see I've got publish single file equal true, and I have publish trimmed equals true. Publish trimmed equals true basically tells us to try to go guess what parts of .NET you're not using and throw those DLLs away. So let's run this.
I always like to explain that. They call it tree trimming, right? You kind of hang your application upside down and you shake the tree really hard, and then the leaves that fall off are all the bits that you don't call, the functions you don't use.
Exactly. And that's an area that we will invest more and more in the future as we go. I want to make it easier, and we want it to be more aggressive as well in the future. So I ran it for 3.1.
Okay.
And now I'm going to run a 5.0 version of the exact same thing.
All right.
And while I'm waiting on that, let's just open up that 3.1.
All righty.
And I'll drill in here.
Do you want to be an obj or bin? You're in the obj folder or the bin folder?
Actually, you're right. I jumped in the wrong one.
There we go.
Let's get some bin. And we'll go in the publish folder. And you can see I've got about a 45 meg, 46 meg .NET web application.
And that includes basically all of .NET, everything that you'd need. It's more than just Hello World. It's a lot of stuff that came along for the ride.
Yes, that's a bunch of stuff. But that's, as you said before, that's self-contained. No .NET has to be on the machine. You just copy that to a machine and the app just runs.
Right, and you said release -R Win 10 x64. It'll just work on any Windows machine. You just double click it and it works.
Right. So let's do the same thing on the .NET 5.1 and take a look at that.
17.5 megs.
17.5 megs compared to 45 megs. So this is just, as I said, I think of .NET more as a journey than I think of things as like, oh, it's going to be magical in one release. No, we keep working on making it better and better as we go. So let's drill into that folder for fun.
And in the past, with .NET, with the early versions of the single file stuff, and there's lots of ways to do this. There's been a number of open source solutions for this that were kind of simplistic. You would basically put all of .NET in a folder, zip it all up, run it. It would unzip itself into a temp folder and then run itself, which works, but you're doing a lot of file I/O. You're reading, you're writing, you're reading it back. Antivirus systems could get upset about that. What we really want to do is just read it and run it all in one swell foop, as they say.
Right. And I just want to prove that it still runs.
Okay.
So I only jumped in here just to say
that would be a good proof.
A fake.
Oh, and it's a web app too.
And it's actually it's .NET New Web.
Oh yeah.
So it's and it will actually return stuff. So it actually works. So it's that's a huge improvement, version
That's
to version
great.
from .NET.
I love it. And that having those small little applications that aren't a huge deal to hand to someone, you could send that to a person and they could test it and say, great, that worked. You could put it into containers, whatever.
So I'm going to unplug Scott and I'm going to switch to another computer.
Alrighty. When we do conferences and stuff, they always give you hey, make sure you tell the AV people about all the machines you're going to bring. And then we'll tell them, okay, we'll bring 2 laptops or whatever. And then Hunter rolls in with like 5 ThinkPads and 2 Surfaces stacked up. And then we spend a bunch of time looking. And there's always an AV person who's like, oh my goodness, we didn't bring enough HDMI cables. What? We always try to make as many cool demos as we can for folks. So I assume you have a stack of ThinkPads on the floor. I hope you're using a new Surface Book 3.
I've got a Surface Book here,
Yeah.
Scott. I've got a ThinkPad. I've got a whole pile of stuff.
There's a Mac in there somewhere, probably.
I've got a Mac here too. We'll use it in a little bit too.
I have my Surface right here on my stage. And then I got my Surface Book 3 over there.
So now I'm on another machine, and I switched machines because I'm going to show a preview of some of the C# 9 features. And when you're doing previews, you want to be careful and not break your machine. So this is
daily bits, hot bits, fresh bits.
I just got a couple days ago from the dev team, but they're pretty compelling.
All right. Because I'm all about making things small, making things simple. I did a whole bunch of great videos at .net/videos. Go to the .net website and you can learn about it. So if you know someone, if you love .net, hopefully you do. If you're an hour into watching us, then you want to get other people to use .net. Go point them at our videos. We want to make it easy. I don't want to go and say, public static void main using namespace, right? Make it simple, Scott.
This is using top-level programs. And with top-level programs, if I want to write a single app, single file, I don't have to have a lot of ceremony. I just wrote the using in the right line. I want to show that it does run.
Yeah.
There you go. So it does work.
Love it. But dude, 2 lines, unshippable. There we go. See? Now we're cooking with gas.
But let's go further. I'm going to go to the CS Proj file here.
All right.
And I'm going to change the SDK
to
be the web SDK.
Go back to programs.
So let's simplify this. I've actually got a web app here as well.
Oh, you snuck a web app into the comments.
So here we have a web app in under 20 lines of code, Scott.
You see, I like this. I'm looking at this, but the meat, I feel like, is line 10 and the map.get right there on line 13.
Yeah, for folks that don't know what that is actually some tech we've been building for a while. I just want to show that it actually does run. So that is basically, we call this endpoint routing. And, in some cases, you want to have controller folders and you want to have, page folders and stuff like that. But sometimes you just want to write an API with no ceremony at all. And this is the ASP.NET Core way of just saying, giving a URL, in this case, whack root, run some code. And you can actually mix this with Razor Pages or MVC or Web API, so you can mix and match all these things. And I've done that in some demos in the past. But anyways, this is top-level programs, a C# 9 feature where you can, if you just want to write an app in a single file, you can reduce some of that ceremony quite a bit.
So let me ask you this. Some people say that my obsession with making it simple works great for demos. Like, okay, look, you made Hello World, in one line. Oh, you made Hello World with JSON in one line. What do you think an actual microservice that did something would look like? And when does this go from being a cute demo to being something that's really valuable to make a single file microservice that does something? Because it's almost like bringing that kind of the cleanliness of Azure Functions to a single file. I like to call it server.cs.
So it's a tightrope to walk on going too far to make it a simple demo, For example, that CS file, you might say, well, what if you just got rid of that and just accepted those all defaults? Well, you saw as I moved from a console app to a microservice, I had to go change the SDK to be the web SDK. And so we'll try to figure this out, but you have to be careful. You can't just assume too much stuff, because then it's magic. And then every time we made magic in the past, our customers are like, well, where do I find how the magic figured that out? And so but as you see, Scott, we're making improvements in size on disk, trying to make improvements in complexity of the application. The CS projects are way easier than they were, 4 or 5 years ago. So I think we're going the right direction, and I hope we can get close to what your dream is.
Cool.
I'm going to switch back to my other computer now.
Yeah, I want to make it easy for someone who's getting started to not be scared. Like I think we've all, well, those of us who maybe took some of this in college, we would have sat down and someone teaches you hello world, and they like, don't worry about all that other stuff. We're just gonna this is the line that matters. Public static void main using namespace, all the classes and namespaces. We kind of elide that, we hide that. But could you come up with something that was clean and crisp and micro without being a parlor trick? And that's part of the process, and that's why we do all this stuff in the open, so we can have those conversations. So what machine are we switching over to now, sir?
We're switching back to my other machine, the one we started with.
Okay.
Okay, so let's do a demo of Thai now, Scott. So there's the best way to do Thai is.
Well, you had mentioned before that starting up these microservices, we started a simple one by just running it in Docker. That's just one microservice. And then we talked about single files maybe being a potentially good place for making microservices. But if I got 15 of these things, it's going to be kind of tedious. I tend to make a batch file, start.bat or whatever, and it's kind of lame.
Not a good development experience. So here I am, and I've got a simple app. It's got a front end and a back end,
mm-hmm.
which you would think is not that big of a deal. And we have some stuff in Visual Studio where you can actually run multiple projects at the same time.
Right.
But it can get unwieldy. The more projects you add, it gets crazier, and then the order and all that kind of stuff. And there's a bunch of other problems. So here I am in VS Code. In this application, I've got a front end and a back end. And if I wanted to run this, what I'd probably do is go over here and do a .NET run on the front end.
Yeah, I've been there. And then, of course, like you said, in Visual Studio proper, you go and start up projects. You check the ones you want. You want to make sure that they all start up. And then the ports change on me. That's the one that bugs me because I never know what port it's going to show up on.
I was going to say exactly. I'm going to run this.
Okay.
Let's launch the front end. And because I only launched the front end,
yeah,
it's going to complain that it can't find the back end.
Oh, yeah, you have to start the back end, but you also have to get the port for the back end and then tell the front end about it in config or an environment variable too.
Exactly. So now I'm running the back end,
okay.
But I haven't done what you just said. And so even though I've got both running now,
okay, 44231.
No, actually, they do map.
Okay,
so
good.
That does work, but that's a really bad development process.
Yeah, we've all been there.
And how can we fix that? And so Project Thai is all about solving that problem. So let's stop these things. And I'm going to go back to that main folder, and I'm going to run Thai run. And what Thai is going to do is it's going to go out and find both of those projects,
mm-hmm.
run both of the projects, and build a dashboard for me as well.
Ooh.
So notice it says building projects, launching backend, launching front end.
Okay, launching service. Okay, so it's actually running. I'm looking here. Yeah, it's running it out of your bin debug folders. It's just running them. They're running them as. So this isn't like, I don't see any Docker here. I just see it's tying it all together.
It's tying it together.
Oh.
So now if I go to the first website it gave me, you can see my front end application, and it's got a bunch of the diagnostic stuff here.
Hang on. This is all the new .NET diagnostic stuff that you got. Like these are presented by the runtime, right? And you're pulling them out of. And these are not like in the old days we would do perfmon on Windows, but we need to do that in a non-operating system specific way.
Now, I might still have a problem here.
Okay.
So I can click on the link
Right.
that it's running on.
Okay.
Might still not work because those ports aren't mapping.
Well, it was
There
4
you
something
go.
before. Yeah, I think it was hard coded to 42 something.
They're hard coded, and so
Okay.
I find it challenging to keep all those ports all wired together and hard coded together. So Thai actually solves this as well. I can go into my project here,
Mm-hmm.
and there's a NuGet package we have, and what it will do is it gives you some configuration features for Thai, and so sure. And what I can do then is I can go into my startup file, and you're going to see that in my app, I've hard coded the address for the backend. I'm going to comment that out.
Okay.
And now, so what Thai does is it takes the name of your project and creates an environment variable with that name, and it puts the port numbers in there. And so this line of code basically calls configuration and says get service URI from backend.
I
It's
see.
going to go read that environment variable and stick that in. And so
and when
Thai
you-
is sticking the environment variables in all the processes for me,
Mm-hmm.
and I can write simple codes using things like front end or back end to reference these things.
I see. So when you put together systems like this, there's usually a service discovery agent. The service discovery is a thing. And in this case, Thai is doing a simple one, and I assume you could then plug in a more sophisticated one when you went into deployment.
Yes, and this is also important because when you get to things like Kubernetes, there's a whole bunch of this port mapping stuff. Docker containers have a bunch of port mapping, and letting us manage that for you means you don't have to worry about managing that. So now I'm back in Thai.
Okay. New
I
port
can click
numbers.
Front end.
Just
the
works.
Front end.
Look at that.
Just works. And so this is about making this experience. I can also look at the logs. We didn't show that earlier. I can look at the logs from each of these apps.
And
They're all
again,
there.
this is important. This feels to me, this is about, for lack of a better word, process orchestration, but there's nothing Dockery here. This is just managing the running of stuff. It's doing all the stuff you were showing me you were doing before by opening multiple tabs and making batch files.
Right. Now, imagine that I wanted to bring in maybe a SQL Server or Postgres or a Redis cache. Today, what you would do is you would go and install that thing on your computer, which scares me because my computer's in some state because I've installed some random tool on it
Right.
that might not uninstall very well. What if we could help you with that as well? So I can type Thai init, and what that's going to do is create this YAML file, and I can go back to VS Code, and there's this YAML file.
That's
And now
actually
you can
interesting,
see
by the
this.
way. The fact that you went Thai init, even though you were already using Thai with success, means that it just worked without you having to have any secret config files. This is the first secret config file you've made, and it's right up in front, and it's like 4 lines.
Yes. Super cool.
I like
and
it.
you can see all it does here is it says my front end, project called front end,
Okay.
is based on this CS project file, and my back end is based on this CS project back end
Right?
or file. So that's telling it, here's the services, and in this case, because they're just on my disk, it's giving the CS project file. Now, what I can do is I've got this stuck over here. I can go grab this chunk of stuff out of my notepad, which I saved, and I'm going to paste it in here. And in this case, instead of saying project, pointing to a CS project file, notice I call this Redis, and I point to an image.
Ah, a
That
container
is a
image.
Docker container. And then what I need to tell it is, here's the port. Now Thai is going to do all that magic port stuff for me in my application, but we need to tell the container we have to give it a port. So we run Redis once. You can see we run the.
I see. So the .NET front end and the back end figure their ports out automatically. Thai sees them and tells each other about them. In the context of Redis, you're just setting a known port. Got it.
Now notice I did not write a Docker file. I did not install Docker tools. I'm not doing Dockery things.
You're one layer above Docker.
I'm kind of one layer above.
Yeah.
So let's
Interesting.
save that.
You're one layer above Docker, but you're not trying to be Kubernetes. You're not trying to be a complete orchestration system. This is about development.
This is making development easier for all of us. I'm going to go add one more package reference back. And this is the caching for the Stack Exchange client. That's a Redis client. I'm going to save that. Let's go back. Sure. We'll go back into Startup CS, and because that's a service, I need to configure that service. So I've got the code here. I'm just going to uncomment that out.
Okay.
And notice it uses that same configuration trick. When it configures the Stack Exchange client, it goes and says configuration.getConnectionString Redis. And that's because Ty, once again, is going to stick the right environment variables in the right places, so I don't have to worry about putting ports and stuff.
Right. And the Redis NuGet you added, it's not Ty specific. It doesn't know about Ty. Ty is about tying stuff together. It's not about being opinionated.
Exactly. The Redis I installed is just regular Redis. Now, in my app, I've got this tag helper, distributed cache, and I call it weather. And notice I say, time expires after 5 seconds. And then I wrap all that C# code inside of that. And so what this means is, imagine you're building your application, and I've got a Redis cache now, which I never installed on my machine. And I'm telling it, only run the C# every 5 seconds. Give the cache result outside of that. So let's go back to the command prompt, and let's start up Ty again. Now, the cool thing to me is I never installed Redis on my computer because it pulled that Docker container down. That's all done for me, and I don't have to worry about installing something or uninstalling something. Let's go back to our dashboard in the browser here. Let's refresh it. And look at this, Scott.
Okay, hang on here.
These were projects.
That says project. Those are still running on the metal, I guess, not in Docker.
Exactly.
But
these are running in containers.
But
so now, if I go to my front end app,
okay,
let's refresh it a few times. Notice nothing changes.
Yeah, it's cached.
It just changed. Every 5 seconds it'll change. There you go.
Wouldn't you need a proxy in front of you though? Because you're orchestrating now between projects and containers. Is Ty hiding something from us? Can we see the logs again?
Yeah, let's go. Well, which logs do you want to see?
Let me see the main Windows terminal there. Because things ran by. Let's go ahead and go back to Windows Terminal and scroll up just a smidge. So we see running image for Redis. That's cool. There it is. Running image .NET Core SDK front-end proxy. So in the world of Docker thinks that there's all these images going on. Ty is connecting the networks, allowing us to talk to stuff. But then we see launching service. It's still running on the metal because that's the easiest thing for me to do right now. And I suppose when you wanted to move into Docker completely, you could probably do that as well, eh?
I could. So first, let's go back to the dashboard. I want to show just that we did have this Redis CLI.
Right.
And that was showing all those cache hits that are happening
That's running the Redis CLI monitor.
Yeah. So very easy to compose this stuff together. Let's do one. I think you just kind of asked a question, so let's stop this. Stop in containers, and if I just run Ty here, notice that I have the option. There's a couple options. First off, run. Let's do Ty run, and ask for some help here. And notice that there's an option on the run called Docker. I can decide to have it run all my app in containers. Once again, I've added no Docker files.
Okay.
Now it's going to boot up, and notice it's publishing my projects.
Yeah, I'm watching your logs here. There we go. Look at that. Running image for front end. Running image for Redis. Now it's all in Docker.
It's all in Docker. And once again, I didn't have to learn a bunch of Docker stuff. Go back to the dashboard. Now they all say container.
Ooh.
And so we're just trying to make this experience awesome. I want to show one quick thing before we get to the next topic. And let's go back here. And I've got in my notepad file, I've got this. And I can go back to that YAML file. And right under microservice here, I could go put this in. And what this does, this allows me to run another command, which we're not going to do because it would take too long. But I can come here and notice when I said, when I just ran tie by itself, deploy. So I can now do tie deploy. And because we've given it that registry, it'll go take all of these things, the front end, the back end, the Redis cache, and the Redis cache monitor, and put them all into a container registry. And if I do have a Kubernetes, let's say an Azure Kubernetes service, it would be pulling that registry and pulling the images. And so literally by working this way, I can develop locally. And when I want to go try it in Azure, I just do tie deploy. It goes to the registry and it's running in AKS.
I want to call something out here. We think about Windows and where Windows is, then adding Docker, adding WSL, Windows Terminal, then now tie on the cherry on top that's kind of orchestrating all these things. You've been moving very smoothly between Visual Studio, between the terminal, between your dashboard that Ty brought in, and now you're going to deploy into Docker or Azure Kubernetes service. It's very nice, sir. It's very nice. Just saying.
Pretty cool.
Just saying.
Our goal with the Visual Studio family of products in .NET is to make development easier. And I think we are trying to go tackle these hard scenarios and doing what we can do to make them easier for developers to build and be productive. That's what we do.
Okay. So do you think we have one more thing? Do you think we could blow their minds with a final Holy Mackerel demo?
We have two final demos.
Okay.
Let's do talk about cross-platform native apps. So we're going to introduce something called .NET Multi-Platform App, which we call MAUI. And what MAUI is an evolution of Xamarin Forms. So the idea here is cross-platform native UI. Xamarin Forms has always been about taking an iOS app or an Android, iOS or Android device, and letting you build apps that use those native controls. I want my iOS app to use the native controls. I want to use my Android app to use the native controls for the best perf and the best look and feel. And so that's kind of the idea here is cross-platform native UI.
That's huge, by the way. I've been doing cross-platform UI, honestly, truly, since the mid-'90s. And when I was doing it in a language that we dare not speak its name, it was basically, write once, debug everywhere, and they drew the buttons, and you could tell when you went to another operating system that it was a drawing of a button, and it wasn't a real button. It wasn't a real list box. That's what Xamarin Forms is so great. So then .NET MAUI is taking us to the next level, one project, one code base, real native UI widgets.
Yeah, and we'll show this in a second. If anybody has built a Xamarin app before, you end up with a project for iOS, a project for Android, a project for Windows. You got a shared library. It's a lot of stuff to juggle. We want to simplify that into a single project, and we'll do a demo of that in a second to make it simple. We want to obviously make it easy to deploy to multiple devices. You build that one project, not all those projects, and then deploy to the desktop or deploy to the iOS device or the Android device or whatever. And it's an evolution of Xamarin Forms. We're taking what we've learned with Xamarin Forms over the last couple of years and building kind of the next generation. And this will ship in the .NET 6 era, but we hope to have previews out later this year. Super excited about this. I think you're going to love it. Let's talk about what this would look like from a Visual Studio or CLI perspective. We mentioned before, Scott, one.NET. With one.NET, that means I can now do .NET New MAUI because we use the same SDK, the same tools everywhere. If I'm in File New, it would be File New Multi-Platform App UI. And you can see that we're going to change the namespaces to system.UI. It makes it feel like it's more part of .NET.
Right.
And system.devices. We want, if you're a Xamarin customer, we want to let you know that tech is being bolted into the actual core product. And so you should be excited about this future.
That's really cool.
You might ask, what about the Xamarin iOS and Android apps? They're going to stay basically the same, but to make it very clear that they are .NET, we're rebranding them. .NET for iOS, .NET for Android. And once again, you can see .NET New iOS, .NET New Android.
See, this
the
is
exact experience you would expect if you're a .NET developer.
this is cementing that relationship. Like, this is not a sidecar thing. One .NET means one .NET. You need to be able to go and make WinForms, make iOS, make Android, make a MAUI app. You want to be able to do that, and it needs to feel like .NET because it is .NET.
So while you're talking, Scott, I'm going to switch and bring the Mac
So
up.
I just want to point out that in no way have you broken the illusion that we are together in the same place. It's seamless, truly, from the high quality technology that we at Microsoft bring to you. We are not good at this, but we do it out of love for you all.
So
all right.
Here we are on the Mac, and now I'm going to do .NET New MAUI. Actually, let's jump into a folder first. Would be best.
Mm-hmm.
And so this is showing that MAUI's got that same command line experience you would expect.
Right.
You restore some stuff here to get this running. And these are, crazy hot bits. And we'll run VS Code.
Fresh bits.
And one of the cool things here is this is like the first time we've ever shown building like a Xamarin style application in VS Code. And so there's a couple other fun things that are here. Notice that this is my MAUI app, and notice I'm not using XAML here. All the markup's done in C#. So you can see that I create the main navigation view. I add a vertical stack, a spacer, a label, a spacer, and a button.
Interesting. Now, is that just about choice? Is that just the ability to have the choice of what makes you happy? Because I like XAML. A lot of people like XAML.
It's about choice. Some people like XAML and the MVVM pattern. Some people like this MVU pattern, Model View Update, more. And so we're going to give you the choice to do whatever you like. I'm going to come over here and click this run.
Okay.
And I'm going to select I want an iPhone 11.
Ooh. It's interesting also that you're in VS Code. Another example of choice. You're on a Mac. You could use VS for Mac. You could use this and that. But I've never seen anyone do a GUI app in C# and VS Code on a Mac before.
Yeah. It's super cool. So we'll let that go up.
iPhone 11, 13.4. All right. Ooh.
Ooh, look here. Here's a MAUI app running on an iPhone. Now, I want to show a couple cool things here. First off, notice that alignment's kind of goofy. It's kind of on the left side.
Yeah.
I'm just going to type center.
Ooh, IntelliSense.
And notice I didn't save or anything. Just typing center.
Wait, you didn't even hit Command S?
It didn't hit anything. If I want to change the color of the label to pink, let's do deep pink. It refreshed automatically.
That's cool.
Notice if I've pressed the button, because this is in C#, I'm just writing the count.value ++ right here. If I wanted to make that go backwards, I can not just change the markup, Scott. I can change the C# too. And now it goes backwards.
Oh.
Maybe I want to fix the label. So I just changed the label. And so this is showing hot reload, hot restart, where I can change any of the C# or the markup live in the editor. And as soon as I make that change, the update happens in the device immediately. This is all about getting that productivity to be amazing for the tools. And so that's a quick show of .NET MAUI on a Mac in VS Code building an iOS app.
That's pretty sweet.
Let's switch back to the PC, and we can show the same thing in Visual Studio.
All right, let's switch over there.
Okay, so here you have Visual Studio File New. Now you can see MAUI app right there. I'm going to click the MAUI app here. I've already done that, so I'm going to just open VS back up with an existing solution, and now you're going to see MAUI again. But this time, look. Here's the XAML you're used to. It's all sitting here, all the things you're used to. Mm-hmm. Here's the binding, the same way that you would see binding in a typical XAML application. And so once again, as you mentioned before, we have a choice. You can either use uh, the C# native that we showed, or you can show the XAML. We're going to support both to make everything work great. So I want to run this. Now, we want to make that run experience even better. Notice it says Windows.
Mm-hmm.
There's no emulators. We're going to run this natively on the Windows device.
Oh, it's not an iPhone app. It's a Maui app.
It's not an iPhone app or an Android app. It's a Maui app. And so the cool thing here is we want to make that inner loop as fast as possible. So now you can launch it as a Windows app. And notice you get the diagnostic window over there. You can resize it. As you use it, it looks...
Well, it is a Windows app.
Now, you might ask the question, well, what about if I wanted to run it on a device? Just recently, we've added new support for being able to run on devices, faster than ever using hot reload and hot restart. And so what I can do is I can just plug my iPhone directly into my PC. And when I do, it's going to show up here in the list. See, there's my iPhone.
Okay.
And this is really cool. I don't have to have a developer license or any of that kind of stuff. I can just click deploy, and it's going to go and deploy to my iPhone. And I've got on my machine here, I've got...
Oh, this is not an emulator. Reflector. It's your real physical iPhone.
This is my real physical device running through Reflector. And notice as I tap on my phone, you can see that value go up, go up like you would expect. This is just showing awesome inner loop on Windows without any emulators or any stuff like that. But at the same time, if I want to, I can easily plug in a device and it just works without a hassle of setting a bunch of stuff up.
That's freaking cool. And it looks like Visual Studio because it is, and I'm using XAML.
Look at this. It's a single project. There's not a bunch of projects here anymore.
It's the same project. I got it. Okay, so here's your resources.
Here's my fonts, and my .NET bot is down here.
Nice.
You're sharing these resources across all the applications, no matter where you run them on. And so I don't have to have a section for each one, but I really want to talk about this platform section. It's the coolest. Now you see there's an Android section, an iOS section, a Windows section, and inside of each of these is the code that's specific to that platform. I no longer have to create a separate project to make that work. Now I can integrate all those into a single project, and as we said before in the slides, once I do this, I can just decide whether I want to deploy this to Android, deploy it to iOS, deploy it to Windows. This is showing what this Maui experience is going to look like.
That is pretty freaking amazing. Those are hot bits. When do we get to think about that stuff? When is this a reality? And help me understand this .NET 5, .NET 6 wave.
So this stuff, the Maui stuff is going to come in probably at the end of the year. Our hope is to get a preview out in that time frame. It's a lot of work. And what you're going to see us do is, if you're a Xamarin customer, don't be freaked out that going, oh my gosh, it's going to all stop and wait for this Maui thing. We're going to continue to update Xamarin for iOS, Xamarin for Android, Xamarin Forms, all throughout this development process. Hopefully we'll get some bits to you by end of the year. You can start trying this. It is being developed in the public in GitHub. So you'll be able to grab bits even before we do an official preview. You can actually watch us do all this kind of live.
Why don't you share your slides as I go over some of the things we've seen today? We went through Blazor, WASM, WebAssembly now happening. We did ML.NET, amazing ML.NET example where we brought in that car rental application. We went through microservices, saw WSL2, hit F5, runs in WSL2, ran a bunch of stuff in Docker. Then he showed the single file stuff. That was amazing. We saw we switched over to your other machine and saw a preview of C#9 coming soon. You ran multiple apps with Project Ty, which is in preview, and then just now .NET Maui also in preview later in this year on a Mac and on Windows, both native applications. That's fantastic.
There are previews of .NET 5 available today. Preview 4 is out there. Go grab it if you want and play with it. Give us feedback. I do want to talk about one more thing too. A lot of customers, as we ship .NET Core 3 especially, asked us about, what about UWP? When is UWP coming to .NET Core? And the answer is, there's no plans to do that. And that's because the Windows team is introducing something called WinUI. And WinUI is the next iteration of UWP, but it doesn't have some of the limitations. It doesn't have to run in an app container. It's Xcopy deployable, like most .NET Core projects are. It runs on all versions of Windows 10. And they're building this with support, so it will run on top of .NET 5. So you'll be able to grab their SDK and run this on top of .NET 5 if you want. So if you're a UWP developer, I would say stay where you're at today, and then watch this WinUI project as a great place to move your UWP apps when it's available and ready.
Very cool.
We've talked about this schedule a lot of times, but I want to keep talking about it. We want to be very transparent with you folks. Every November we ship a release. You can count on that every year, and every other year it's an LTS. So as Scott mentioned earlier, .NET 5 is not going to be an LTS. It's going to be a faster release, which means if you want to use it, you have to stay on the latest version to be supported. But all of the stuff we showed today will all coalesce together into .NET 6, and that will be the long-term supported version. So next November, it's going to be really crazy when you get all of this stuff together. Predictable, easy to understand, I hope. And we have another awesome announcement, which is .NET Conf. This is our .NET only virtual event. And we are going to launch .NET 5 in November at this event. It'll be a couple of days, and it'll be some of us, some of the community, all building all kinds of crazy stuff on .NET 5. And so mark your calendar now and wait for this to come. It's going to be a lot of fun. And call to action, I said this before, if you're a .NET customer and you're building new apps, you should be thinking of .NET Core 3.1 right now. That's the place for your new applications. If you want to, because these are side by side, you can also install the .NET 5 previews and kind of follow us along the journey of .NET 5 until it releases in November. And so we'd love you to try those and give us some feedback if you can.
All right. And then that's it. That was pretty good. I felt good about that.
We have one more thing, which is, thanks for hanging out. And there's a link here. If you want to give us feedback, we'd love your feedback on .NET 5. We showed a bunch of stuff today, and we'd love to hear how you feel about it and what your thoughts are. Thank you very much.
Awesome. Good job. Mic drop.